Okay, so we will be discussing this model from scratch. Okay, in last video I told about the functioning of the solar power electric vehicle charging station. So here we'll build from scratch. So initially let's take a see left hand side I opened the build model so you can understand. But I will suggest you to follow the right hand side screen. Why? Because I am creating it from scratch. Okay. So let's say you take a photovoltaic array. It is directly available in the Simulink block set. So take a photovoltaic array, and if you see, it is asking two things as an input. One is irradiation, one is temperature. Okay. So I can give temperature also as an input. First of all, click on the block. If somebody is new, he can understand. Go and check show block name. Double click on the photovoltaic array. The block properties gets opened. Okay, see the block properties. Parallel string I want 3, series I want 120. User define I don't want. I can select some company. For example, let's say I am taking A110 gain technology. Maximum power is mentioned. Here array at the rate of 25 degrees Celsius and specified irradiance I have to give. Okay, so because I want to give specified irradiance, I don't want to fix the irradiance because if you see the third option, okay, it's array at the rate 1000 watt per meter square and specified temperature. That means temperature will be the manipulating factor. If you see the second option here, temperature will be fixed 25 degrees Celsius and irradiation will be the manipulating factor. Correct. So both is not possible. Okay, either you can change the temperature or you can change the irradiation. Correct. So I'm going for the second option because I want to manipulate the irradiation. Click on the second option. Pick on the second option. Click apply and click OK. So your maximum power gets updated as per A110 gain technology. Press OK. See, since I mentioned the temperature 25 degrees Celsius, okay, I have to give with the help of the constant block. Any arithmetic values or you can say mathematical values I have to give via constant block. So take a constant block. Okay. Search on screen, press left click and search constant. Okay, you can rename it. Let's say it is a temperature. So TEMP temperature. And make a copy of this. How to make a copy in simulation? Right click and this is irradiation. Just go and left click once on the name and just change the name irradiation. I told you irradiation means how much is the sun intensity measured in watt per meter square. Measured in watt per meter square. Right. Clear. So temperature I have to fix 25 because I selected that option only. Irradiation I will manipulate with the help of the some type of knob or some type of see you can see the left hand side some type of knob or some type of dashboard I will be using. So my photovoltaic array has how many cells in series? 120 cells, 3 cells in parallel, and I choose the company A110 Green Technology. Maximum power 184.7 watt. Okay, connect temperature to temperature, irradiation to irradiation. Perfect. This photovoltaic array is set with the temperature. Irradiation I have to manipulate. Okay, now the output has to go to boost converter. The output of the photovoltaic array has to go to boost converter. Okay, so you have to design one boost converter. So what I am doing, okay, I will make one subsystem for the boost converter. What is the meaning of subsystem in Simulink? You can see on the left hand side, inside you can build something and outside you can keep as a system. So take a subsystem block. Okay, this subsystem block I can name as a DC-DC boost converter. Why I am using boost converter? because the voltage of the photovoltaic cell may not be proper, so I am using the boost converter. Right. Increase the size of boost converter. Okay. Double click on that. De- Delete this part. Okay. So it's a blank subsystem. You can see. Okay. So how to connect the connections put inside and that thing. Okay. Just go inside, and if you see here, I took one positive and negative. So if you make a connection port here, see, actually this has to go inside, but it is created automatically if you press plus and minus and it goes inside. Okay, you can see the software automatically created the connection port. It's a connection port. If it is not creating automatically, you can double click and take the connection port block. Type connection port, click on it, so block name, copy it. Okay, name the first one as a positive photovoltaic input. Okay, second one as, let's say, name as a negative photovoltaic input. Negative. I think I mistyped something. For understanding, let's say positive photovoltaic, and let's say it's a negative photovoltaic. Negative photovoltaic. Okay. Okay. If you go outside, you can check that two connections ports are created. If you see some preview is coming for the boost converter, you can right click and go to format and check the content preview. See, positive connect to positive, negative connect to negative. But actually, what I am doing, I am using one capacitor for the safe side. Okay, so connect one capacitor charge storing device. So I am using for my safety. So take a capacitor here. Okay, and you don't take direct capacitor. Actually, it's a SimScape. SimScape means it's a real time. Take series RLC branch, change to capacitance. Okay, and press Control R and decrease the size of the capacitor. Okay, so it will adjust positive to positive, and again it is going inside of the boost converter block. Negative, negative, negative of boost converter. See, measurement port, you can decrease the size. Okay, so if you go inside, you can see positive of photovoltaic, negative of photovoltaic. This positive, these are two connection port for the photovoltaic cell. Nothing I did special as of now. I simply connected positive output of the photovoltaic array and to the boost converter system. Why? Because we have to create the boost converter circuit here. Either you can completely create the boost converter circuit, or else you have a directly boost converter here. Take the boost converter. Okay, not this one. Okay, take the Simulink boost converter, second one. Okay, and come inside, and here change to average mode. Why? Because you want it to be controlled by the duty ratio. Last video please refer. Okay, duty ratio is important. We want to control by the deconversion. Please apply, please apply. Okay, right. So I have to give duty ratio, correct? No. So for giving a duty ratio, I want one duty ratio port. So in port you can use. Input means input. Name as a duty ratio. So what will happen? You can give the duty ratio as a input. That will be decided by the MPPT algorithm. Correct? No. Positive should go to plus, and connections is there simply. But I am using again series. RLC block. Why? Because I am want to connect one R and L. Just let me know in comment why I am connecting this R and L. Okay, right. Also, let me know if you go outside. I connected one capacitor, so that also let me know why I connected. Anyway, I'll be telling in some videos, but just let me know. Maybe some college students they will be familiar with this thing. Okay, so go inside. Values you can see here left hand side. I have the values 0.005, 5 to the power minus 3. 0.005, 5 to the power minus 3. Applying. Okay. Done. Positive of PV input. Okay. We'll go to 1 from this side. It will just close the loop, as simple as nothing at its special. And this positive again I am storing in, this is the output of boost converter. So again I am creating one connection port copy, third and fourth. Select this both controller. Okay. Name it as a positive of boost. Just a connection. MATLAB is very much easy. Okay. Even the mechanical students also can easily learn and make the career in this field. And I also uploaded two career based series also for the automobile and the electrical electronics engineer. Okay, it's a highly demandable MATLAB based course. Positive to boost, negative will go to here. Right. One BL is there. So these three tasks you please pass in a comment. Why BL is used? Why I use this inductor and cap resistance, and why the here capacitor. Okay. Take a constant, connect to BL. Okay. It's actually a blocking input. I am just giving you a hint in terms of name. Blocking input. Right. Perfect. So the output of the boost converter you will be getting an outside. See. So keep this. You can just pick on it and move on the right hand side. Pick on it, move on the right hand side. So you have a positive boost and negative boost. Perfect. No. Name as a negative boost, not positive. Yes. See. Duty ratio will be controlled by the MPPT algorithm that we'll discuss on. Hope it's clear as of now. Photovoltaic array boost converter. Nothing special I am doing. It's all the basic. Even a person who is belongs to basic science, he can also understand the simulation. And simulation is very much important. Why? Because if you go to any industry, the skill set they want is the simulation. Okay, let's take a battery pack subsystem. Take a subsystem. Okay, come inside, delete this one, take a battery, it's available directly. Take a battery, and if you see the battery I took is 48 volts, 65 ampere hour. Double click on it, change the parameters, 48 volts, 65 ampere hour, 25% charge. Why? Because if I keep 100% I can't see the charging. So 25% charge, 48, 65 ampere hour. You can name also 48 volt, 65 ampere. Correct. So now the positive of battery and negative of battery has to connect with the boost converter. Simple. So I have to take this port outside. So for that connection port is used. Even output also you can use. Okay. But better to use connection port here. Right click, go to format, content preview, turn it off. Name as a battery pack underscore 2. It's a professional way of naming. Okay, go inside, take a connection port, copy the connection port, name one as a positive of the battery, name second as a negative of the battery. Control I, positive of battery and negative of battery. Okay, so this will go outside. If you see positive connected to boost positive, negative connected to boost negative. Okay, so now if you see, okay, if I don't want the current to go back to the boost converter, for that purpose what I am doing, I am connecting one diode here. Okay, the diode you can see, you can take directly. See, don't take Simskip diode, take Simulink diode. See, see, initially it will be difficult for you, but don't watch the video in 2x speed and all. Just watch it. I mean to say, normal. You can understand. It's not so much difficult. See, so all things are set. What to measure from battery? A measurement board will give you the measurement of the battery parameters. What are the parameters I can measure? You can't measure directly. You have a bus selector. Take a bus selector. Okay, M means measurement. It will give the measurement of the certain things. Okay, but you can't measure it directly. You have to go for the bus selector. Left hand side is input, right hand side is output. Select on the block, press Ctrl I to reverse flip the block. Initially, try to show the name of the block. Whenever you are practicing, especially for the fresher who is new to the MATLAB or Simulink, suggest you to initially, okay, see the block name properly. Bus selector will select the signal coming from the measurement port and it will give the things that I can measure. That is decided by the MATLAB. You can't decide. So what are the selected elements? Signal 1, signal 2. What are the available? SOC, current and voltage. Right. So these are the available signal parameters. These are the selected parameters. I don't want signal 1, signal 2 because that is a residual signal. I don't know what is signal 1, signal 2. Select on that, remove. Click on it, remove. Press Ctrl, select all the three, press select, it will come on the right hand side. So now right hand side is my selected element. Okay, so I can see comfortably SOC current input. The rules is same for the every measurement port. Based upon the selection of the original pack, you will be getting the option. For example, it was a battery, so I got the option of SOC, voltage and current, right? You can see this graph. To see the graph, use a scope. Take a scope and just reverse it. How many inputs required for a scope? Double click on that. Okay, three, because I have three SOC. One is current, one is voltage. Go to setting, pick three, apply. Okay. SOC, increase the size of the scope. SOC to first one, current to second one, voltage to third one. Right. See, a perfectly 48 volt 65 ampere hour battery with a positive and negative terminals, okay, is ready to give me the SOC current and voltage. This SOC, okay, uh, you can, I want to see outside, so I will show you how to prepare a dashboard. Okay, just go outside, see. Perfect. Yeah, duty ratio. Okay, we have to, you have to give via MPPT algorithm. this duty ratio we have to keep by maximum power point tracking algorithm. Okay, so I have to first make you understand what is the meaning of MPPT algorithm. Okay, so if you see my first video, you can understand that. Okay, the working principle. In this video, I modeled everything. Okay, only the duty ratio part is pending. Okay, so please stay tuned for the next video. In next video, I'll be discussing about the MPPT algorithm, and then we will complete the model. So you have to watch all the three videos. Videos 1, videos 2, videos 3. In videos 1, I am explaining the overall functioning of the solar powered electric vehicle charging station. In video 2nd, I modeled everything except the MPPT algorithm. In model 3, I will be explaining about the MPPT algorithm in brief and will implement that in the model. Please stay tuned for the next video. Bye bye.